Hello everyone, welcome back to the channel. In this video lecture we shall solve this problem, edit distance. In this problem we're given two strings A and B, and we have to convert string A into string B, and the operations that are allowed so as to convert string A into B are: the first operation is inserting a character, the second is deleting a character, and third is replacing a character with another character. Okay, and we have to convert A to B in minimum number of operations. The input format is: the first argument of the function that we will be given here will contain the string A, the second argument of the function will have string B, and in the output we have to return an integer which represents the minimum number of steps required. Okay, and the length of the strings goes up to 450. Fine. So let's better understand the problem statement using an example. So here we have string A, which is intention. We have to convert it into string B. Okay, and these are the operations which are allowed. Okay, so let's see how we can do this. So if we move from the last character, so they are matching, so we skip to the second last. They are also matching. O is matching with O, then we move to the previous character. I is matching with AI, so we move to the previous character. T is matching with T, so N is not matching with U. So here what I have to do, I have to perform some operation out of these three operations such that N is converted into U. Fine. Either I insert a character U here, so I take another character U and insert here, so I shift this string to the left. Fine. Or I delete N and then I compare this string with this string. Fine. Or I replace N with U, so I replace it with U. So these are the three operations that I can perform here. So which operation will be most suitable? That we have to know. Fine. But all three operations will definitely convert the character into the character which is required. Fine. So all we have to do is to check out which operation is most optimal. That means what is the operation here that I have to perform, which gives me the total number of steps, total number of operations to be minimum. Okay, so that's the problem. For this example, ABAD, so let's take another example, ABAD, which is given in this problem statement. ABAD, we're converting it to ABAC. Okay, in this operation all we have to do is to replace D with C. Okay, that's all. Hence the answer is 1. So let's see how we can solve this problem. This problem is named edit distance. Namely, all we have to do is to find the distance between these two strings. Also, the lengths of strings A and B can be different. Fine. So let's see the intuition to solve this problem. So as we see that at each step where the characters are mismatching, we have three options. Either we perform an insert operation, or a delete operation, or a replace operation. So the most naive and brute force way to solve this problem is to check for all operations. Namely, wherever I find a mismatching character, I try to insert the character which is required, I try to delete the mismatching character, I try to replace the mismatching character. Fine. So that's the brute force way to solve this problem. So what I am doing here is I start from here. N is matching with N. Fine. Move to this character left. O is matching with O. Move to this character. I is matching with I. Move to left character. T is matching with T. Fine. Move left. N is not matching with U. So here what I will do, first operation that I will perform is insert. Insert U here. Okay, so I insert U. That will give me a character of string as int 10 n u t I o n. So this is what I want to do here. Fine. Another operation that I can perform is delete. So I delete the character u. Okay, that will give me the final string as, after deleting character n, sorry, it's not u, it's n, the final string will be int 10 t e u t-e-t-i-o-n, because I have deleted the character n, and now I have this prefix remaining inte, which I have to match with this execeu. Fine. The third operation that I can perform is to replace. That means simply replace the character n with character u. Replace n. So that is giving me a string of int t e u t I o n. Okay, so after performing this operation, I have this much suffix as matching with the suffix of the target string. So ution, ution. So now I have to match this prefix with the remaining prefix of the target string. Now I move to left by 1. So again, the character C is not matching with character E. Okay, so here I have three options, namely insert, delete and replace. Then perform all three of them. After deleting n, I have this prefix to match with this prefix. Okay, that is execeu. Now I see that u is also not matching with e. So again I have three operations to perform. Okay, finally I move to the operation insert. This string, I build this string after inserting character u. Now I have to match this prefix int with this prefix exec, but I see that n is again not matching with c. Okay, then again I have three operations to perform. So that's how I proceed in this problem. So that's the intuition to solve this problem. At any mismatch character, I try all the three possible operations, and then whatever the result they return, namely like I perform one operation here, so the number of operations will increase by 1 here. So here the operations were 0, it will increase by 1, so it is 1 here, 1 here, and here it will become 2. At this level the operations will become 2, and so on. So whatever subtree returns me the minimum number of operations such that the entire string, the initial string, is converted to the final string, that subtree is giving me the right answer, or the minimum number of moves to convert that initial string into the target string. Okay, so that's the idea. Let's see how we can implement this in practice. So we can see that this problem is the solution to this problem is a recursive solution, because like it is clear from the intuition itself. Okay, so let's see how we can build that solution. Imagine a function added distance which takes in the lengths of the strings. M and n are the lengths of the strings. Okay, and gives me the minimum distance or the minimum number of moves to convert string x into y. Okay, so this is the substring that I want to convert. So x from 0 to m minus 1 and to y from 0 to n minus 1. Initially this function is called, let's call it ed, is called at last index, and the last index is 3, and for string y it is 4, because the length of the string x is 3 and the length of string y is 4. So this function is going to give me return me the minimum number of moves to convert x into y. Fine. So this is a recursive function because we have understood why here. Let's see how the body of this function will look like. Okay, so we see in this edit distance function, one of the condition will be if the characters are matching. So let's say the last characters are matching here, then all we have to do is to find the answer for the remaining substrings. So since C and C are matching, the answer will be the final answer will simply be the number of moves to convert AB into DCK. So all I have to do is to skip this character. So we do not perform any operation here, we skip the last character and we call the same function for the remaining strings. Fine. So this is one of the conditions. Otherwise, if the characters are not matching, like they are not matching here, what we have to do is to call the function edit distance for three different operations. The first operation is we simply insert k here. So we insert k here. In that case, the x will become A, B, K, C. Okay, so now K is matching with K, but we have, so let's say initially the length of the prefix was 2, but now the length of the prefix is still 2, which I have to match with the remaining prefix of string y, which is DCK. Okay, so this function will be called on the prefix of same length for string x, but the length of the prefix y will decrease by 1 because one of the character has been matched. So now I will call the function for the prefix DC and AB. So for this, the first call will give me ED 2, 3, because the character number 3 and character number 4, that is C and C, were matching. So I called the function on prefix AB and prefix DCK. But here I see one of the operations I performed is to insert, namely just inserting character K here. So that for that I call the function ED on the prefix of length 2 and for string X, and prefix of length 2 for the string Y. So I do not change the prefix for the string Y. Why? Because all I did is just put another character K, the pointer didn't move. Fine, that's why this remains the same, while the pointer for Y, for string Y, moved to left by 1 because one of the character has been matched. So now it is DC. Initially it was DCK. Okay, so this we call as insert operation. So this is insert operation. Another operation that I have to perform is, we know it is deleting a character. So B is not matching with K, just delete B. In that case, I will have A as the remaining string to match with DCK. Okay, so in that case, what will be the function call? If I delete B, then I have to match A, which is of length 1, with DCK, which is of length 3. Fine, so this is the delete operation. And the third operation is replace. B is not matching with K, I simply replace B with K. In that case, the string will become A, K, C, right? Now K is matching with K, I have to match A with DC now. Fine, so the pointer for both the strings will move to left by 1. So ed will be called at 1 and 2. Fine. So now I have performed 3 operations for the string a b c at character number 2 where it was not matching, and so on. And the number of operations will become 2 here. Sorry, it will become 1 here. The operations is 1, but here it was 0. Okay. Now the this will return some answer because I have AB to match with DC. This will return some other answer because I have A to match with DCK, and so this function will return some answer where I have A to match with DC. Okay. Now whatever function call is giving me the minimum answer, that will be the final answer which this function will return to the calling function. Fine. So this gives us some idea how the body of the edit distance function will look like. So let's say the function is called for at index 3 and index 4, index 3 of string x and index 4 of string y. That's why I'm putting 3 and 4, which represents the lengths of x and y. Then this function will in turn call the function for these prefixes. Why? Because last character, observe that the character c of x is matching with character c of y. So we do not have to make any operation, we do not have to make any move here. All we do is to just try to match the remaining substrings. So I try to match AB with DCK. Okay, so I move both the pointers by 1 to the left. That's why I'm calling the function at 2 for the prefix of length 2, prefix of string x which has a length 2, and prefix of length y which has a length 3. Fine. And I do not perform any operation. That's why the operations were 0 here. They are 0 here as well. Then we see that B is not matching with K. B is not matching with K. So we have 3 options. The first one is to insert a character. So initially here I'm inserting a character. So what I'm doing, I'm converting the string like this. The string after inserting K will become ABKC. Okay. Now KC is matching with the KC, and I have to deal with AB and DC. I have to match AB with DC because KC is already matching. But here I have performed one operation. The operations were 0 here, but I have performed one operation. And whatever the operations this function will return, that is the operations to convert AB into DC, I will add those operations into 1. And that will give me the final number of operations to convert the entire string x into y. So that's the idea. Hope you're getting it. Then I perform another operation. I try to delete the character. I simply say B is not matching with K. Fine, delete it. The target string will become, the string that we are converting, it will become AC because I have deleted B. But now I have to match A with DC, with DCK. So that's why it is 3 here. Okay. So that's why I am calling the same function at for this prefix A and for this prefix DCK. And I add whatever the result this function will return to 1 because I have performed one operation here. Similarly, I perform a replace operation. I'm saying, okay, B is not matching with K, simply replace it. After replacing the string that we have, it becomes AKC. Okay, now KC is matching with KC. Okay, then I have to match A with DC. So I call the function for these prefixes, for prefix of length 1 of string x and for prefix of length 2 for the string y, and the operations will increase by 1 because I am performing a replace operation here. That's all. Now I have here I'm matching AB with DC, and we see that B is also not matching with C. Then I perform same operations and increment the answers by 1. Okay, so I keep doing this until unless I exhaust both of our strings. So when X and Y are exhausted, then I have to quit. That will be the base case of our solution. So imagine the scenario when one of the strings is exhausted. Let's say here X is exhausted, but we still have some characters in Y which I have to match. Let's say the X is converted to C, K, Y after a couple of operations, but the target string that we needed was DCKC. So how would I compensate for D? All I have to do is to insert D here. That's an insert operation. Fine. So let's see the base case. I hope you understood what is going on. So we can now build the body of our edit distance function. So this is how the edit distance function will look like. In this function, this is the first condition where the characters at M and N are matching. If they are matching, all we have to do is we simply call the function for the previous prefix. So we are calling the function for the prefix that we want to match, because the character number M of string X and character number N of string Y has been matched here. Fine. Now we have to match the string from 0 to M minus 1 and Y from 0 to N minus 1. Okay. And we haven't performed any operation because the character was already matching. But if it is not matching, then I perform 3 operations. I keep M same because this operation represents a insert operation. Why? Because if I am inserting nth character, the character which is present at nth position in string Y, into mth position of string X, then that means the length of the string X is incrementing by 1. So the prefix that I had to match before, like here K was not matching with B, I bring K here. So now K is here. The string becomes ABKC. Now I have to match AB with DC. Initially I had to match AB with DCK. Now I have to match AB with DC. The prefix length stays the same here for the string X, but for string Y, the prefix length has decremented by 1. So that's why I am calling the same function for M and N minus 1. This is delete operation. That means if the characters are not matching, B is not matching with K, I delete B and I try to match A with K here. This is the X after deleting the character B, but now I have to match a prefix of length 1 with the prefix of length 3. So that's why I'm calling the same function for M minus 1 and N lengths. Finally, I have replace operation. In this operation is simplest because this means I am simply converting B to K. So B is converted to K. So now I have to call the function for a prefix of length 1 and for a prefix of length 2 here in this case, because I have converted P into K. Fine. So both have the lengths of both strings have decreased by 1. So that's why I'm calling the edit distance function for M minus 1 and N minus 1. And whatever the function return is, whatever the minimum will be, okay, that I will add to 1, because I am performing at least one of the operations, either insert or delete or replace. That's why I'm adding 1 here. Fine. So that's how the body of this function will look like. But notice that something is missing in this function, which is the base case. How would I end my recursion? For that, imagine the scenario when we have exhausted one of the strings. Let's say I have matched ABC. I was matching ABC with DCK. I have converted ABC into CKY. Fine. But the string that we required was DCKY. So I have one operation to remaining. Okay, so I have one operation to remaining. That is, I need one character D here. So I want to insert D here. But I have already exhausted the string X. So in that case, the M has become 0. But N is not 0, N is 1. Because there is still a character which I have to match with some character. So if M has become 0, the only choice that we have is to insert. So insert D. Okay. So if it was of length 2, let's say we have matched KY with KY and C is not present. We wanted to match. Okay. So N is the remaining characters that we have to insert into the string X. So if that says if M has become 0, I have exhausted the string X, then whatever the characters string Y has, the remaining characters, I will simply insert those characters into the string Y. So if M has become 0, insert remaining characters of Y into X. So that is the operation. Another case is that if I have exhausted the characters of Y, but I still have characters in X which I have to match, then I have to delete those characters. So I delete the remaining characters of X in that case. That means, let's say, let me tell you, let's say I want to convert DCKY into ABC. I have converted this into ABC, like I have converted DABC. In that case, this character is still a redundant character which I do not require in my final string. So this is string Y, this is string X. I wanted to convert X into Y. I have converted X into string DABC, but I have an extra character. In that case, I will simply delete these characters. So if M becomes 0, the operations will be N, and if N becomes 0, then the operations will be M. So that's the case I have written. Exhausted the string X, fine. Insert N remaining N characters of string Y into string X. Exhausted the string Y, fine. Delete M characters of string X. And rest stays the same. So that's the final recursive implementation for the edit distance function which I explained here. Now, okay, so let's discuss the time and space complexity for this solution, for this recursive code. Observe that in this tree, each function may call to 3 functions at max. So that's why the branching factor is 3, while the height of the tree may goes up to maximum of whatever the lengths of strings X and Y is. So you can see this, observe this branch. Okay, so that's why the time complexity will be exponential. It will be 3 raised to the power max of N and M, where N is the length of string Y and M is the length of string X. So this is the time complexity for this recursive code that we have written, that is big of 3 raised to the power max of M and N. And this is exponential time complexity, which is not very good, because let's say for M up to 100, the number of operations becomes 10 raised to the power 100, if n is let's say 10, which is a very bad time complexity. It will not work. So for a string of length 100 characters, the code is not working fine. So that's why we have to improve upon the time complexity. So that's the time complexity for this solution. We have to improve upon it, and we know that for a recursive code, to improve upon a recursive solution, we have to perform memoization. How? Observe in this tree that some of the functions are redundantly computed. How? Here you can see that I am calling this function ed11 here, and here again. Okay, same goes for function 12 ed12 for a prefix of for the prefix a and dc. Here this function is being called here, it is being called here again. So this is a redundant computation. First, once I have computed the results for this function, I am computing the results again here, which is not required. Rather, we can memoize the results that are computed here, and I can reuse those results whenever I require them. So that's the idea of memoization. I have to perform memoization for this recursive code. But how would I perform that? Notice that I have two indices, two variables which are changing. So I'm changing the pointer, I'm changing the length of the string x and the length of the string y. So for the memoization, I require two variables. So for the DP table that I have to prepare will have two dimensions, I and j. I stands for this character, j stands for this character. Fine. So that's the idea of memoization. Okay, so this is how I am implementing the matrix. Let's say m is the length of string x, n is the length of string y. Then the dimensions of the table that I will prepare will be m cross n, or m plus 1 cross n plus 1. Okay, so let's see how this can help us avoid unnecessary computations. Here, so this is the memoized code. What I am doing, I'm simply first I have to initialize this array with -1. So I declare my array dp in my final code, and I initialize it with -1, such that I initialize it with -1 because this is used to check whether for a particular set of indices ij. Okay, so let's say ij here, if the results are computed or not. If -1 is present, that means the results are not computed yet, so we have to call the function at that position. Otherwise they are computed, and I return those results as per requirement. Okay, so here I am, for if I exhaust the string x, I return n. If I exhaust the string n, I return m. Fine. If the results are already computed here, then I return those results. If the characters are matching, I call the function for the previous prefixes. Let's say for some string x. Okay, so this much length, and so this much length is matching, and for the string y, so this is the length which is matching, and I have to call the function for this remaining length. So this is what I'm doing here, and I am storing the results for the corresponding indices m and n in the memoization table. Similarly, here in this here what I'm doing, whatever the answer that the result of this function will return, I will store them in dp mn. So I have forgot to write the table here. So dp mn is equals to 1 plus minimum of edit distance calling for insert, edit distance calling for delete, edit distance calling for replacement. Okay, so this is how I am memoizing the results. This is very easy. Let's see how this has helped us a lot to reduce the time complexity. Okay, so here you can see that the time complexity has improved because I am not calling the redundant computations. So let's say if I have m indices for the string x and n indices for the string y, the worst I can call is m cross n indices. The number of possible pairs, unique pairs, are m cross n, you know, because the first index can be paired with 2, 3, 4, 5, and the second index can be paired with 3, 4, 5, 6, and n, and so on up until m. Okay, so this represents the characters for string x, this represents the characters for string y. So the number of possible unique pairs are m cross n. So that's all. That means the function that I'm calling, like 2, 3 will always be called exactly once. I will not call 2, 3 again anywhere. I will not call 1, 3, 1, 2 again anywhere. Okay. Similarly, it goes same for all the possible pairs. So all we have to do is to count the unique pairs of I and j, and we know the number of unique pairs are m cross n. So, and that's the space complexity. The space complexity is big of m cross n. Okay, and okay, so it is also the time complexity. The time complexity is also m cross n, and the space complexity is also m cross n. Or I'm storing. Okay, so that's the time complexity, big of m cross n. So what is the space complexity? Since I'm using a DP array of dimensions m cross n, the space complexity will also be m cross n. Will this work fine for the constraints that we have? And the answer is yes. The constraints that we have, the length of the strings goes up to 450. So 450 into 450 will give me, let's take it, let's not take it 450, let's take it 500. So 500 into 500 will give me 2500, 250000, and the number of iterations that a CPU performs are 10 raised to the power 8, which is giving me 0.0025 seconds. Fine. 4 to 6 to okay, so this is within 1 second, which is the time limit for most of the online judges. So this will work fine for this problem. So that's the solution, the memoized code for edit distance problem. Okay, we can try to submit this solution here. It will work good. Let's see the code implementation for this solution. Okay, so this is a memoized code for the edit distance problem. This is the edit distance function, which gives me the minimum number of operations to convert the string x into string y. I'm initializing the DP array with -1 here, and I'm calling the function after that. So this is the implementation in C++, this is the implementation in Java language, and this is the implementation in C++. Fine. Okay, so that's all for this video. Okay, that's all for this video. In the next video of this series, we shall solve the same problem at a distance and build the solution in a bottom-up manner. So this was a top-down approach. So there are two approaches in dynamic programming, top-down and bottom-up. So top-down is basically memoizing the recursive code, which I have done here. The another approach is a bottom-up, is building the solution in a bottom-up manner. So I will also solve this problem at a distance using that approach in my next video, and I will also optimize the space further. Fine. So thank you so much for watching this video. Hope you see in the next video. Thanks. Bye.